In part 3 of section 16, we're going to be looking at transformations again. So that's going to be a revisit on the concept from earlier in the semester, and we're going to be using example 16.6. It says use the graph of f, and f is given with a domain restriction of 0, and the equation for f is f of x plus 1 equals 1 over x squared. And we're supposed to use that to graph g of x is equal to 1 over x minus 1 squared minus 2. When we did transformations back in, I believe it was section 4, we had talked about being able to recognize where are the multipliers and where are the adders and subtractors in your new equation. And if you can identify those and temporarily take them away, such as the minus 1 and the minus 2, then you should be left with the parent function equation, which would be 1 over x squared. And that's precisely why we were given f of x equals 1 over x squared here to use, because it is the parent function for g of x. So make sure that you have your graph for the reciprocal square function handy, because we'll use that for graphing. Now, if we know what's causing the transformations, which would be the minus 1 and the minus 2, then all we have to do is identify which specific transformations are going to apply. The x minus 1, that has always been interpreted as a horizontal shift. And the good news is that everything we learned about transformations in section 4 applies to any new parent function that I give you. So this would be interpreted as a horizontal shift to the right by 1. And then the minus 2 is another transformation, and that has always been interpreted as a vertical shift, specifically down by 2. So I want to be able to apply these two transformations to the parent function, which means I have to apply it to every single point that's on the curve. But the curve is also created a bit by the boundaries, the horizontal and vertical asymptote. Now those aren't technically part of the graph, they're just there to help us get the graph done correctly. So when I do my transformation, that's where I like to start. So I'm going to take the horizontal asymptote and I'm going to shift it down by 2. And then it's going to be located at y equals negative 2. Vertical asymptote is going to be shifted to the right by 1. And that'll be represented by the equation x equals 1. Then I go on to the points. I look at the points in the first quadrant, and I'll start moving each one of those right by 1 and then down by 2. So let me go ahead and do that here. And I don't have to get all of them necessarily, but get enough of them to where you feel comfortable drawing the curve and staying within the boundaries that we've created here. Then I will have another version of this that is going to be on the other side of the vertical asymptote. And if you want to use some symmetry here, you certainly can. The symmetry here is going to be about the vertical asymptote, not about the y-axis. For the parent function, it is still the vertical asymptote, but the vertical asymptote happens to be the y-axis. So do what you got to do, get this thing curved out, and both of those together gives us the graph of G.